This meeting is being recorded.
In chapter 21, problem number 21, we are asked to draw a mechanism for this following transformation. So we're given our reactant here, this diketone on the left, and then we see that we have this cyclic alpha beta unsaturated ketone product here on the right. So we notice that our reagents are sodium hydroxide and heat, and what we expect to have happened here is an intramolecular aldol condensation. So throughout this process, we're going to end up removing hydrogen, and then later on we'll remove hydroxide. But in the end, we're going to be removing collectively H2O. So let's take a look at this process here. So in step one, our hydroxide ion here from the sodium hydroxide will deprotonate this proton here, and then those electrons move in, and we form this enol shown here with the negative charge on that oxygen. Then at this point, we're going to move one of those lone pairs down. That will cause this pi bond here to act as a nucleophile and attack this electrophilic carbonyl on the other side of the molecule. And then some of those electrons in that carbonyl will be moved on to the oxygen here. We will close that ring, and then this methyl group for reference will be over here in the ring, and then this is our oxygen from the carbonyl. So down here's that oxygen for reference. The next step now, we're going to take water here, and we're going to protonate this oxygen here with water. So that lone pair will grab one of those protons. We'll regenerate hydroxide in this step. Then we're going to see this intermediate now over here with that protonated hydroxyl group. Now this proton that I've highlighted here will react with that hydroxide. So we're going to grab that proton, we're going to move those electrons in and form this pi bond here that I just highlighted in orange in this intermediate here. So now we have generated, after the reaction with hydroxide, this new intermediate here. Now we're going to see that one of the, oh, I'm sorry, we forgot one step here. When we deprotonate it and form that pi bond, it would have formed rather up here. That's why I missed it. And then we move those electrons on the carbonyl right there up to form a lone pair. All right, so disregard that arrow that goes down lower. That happens later on. So what we see now with this pi bond in the correct location is that some of those lone pairs move down to reform that carbonyl. Then we kick these pi electrons down a little bit lower to form our final position here of that pi bond. And then at the same time, we're going to force off this hydroxide as a leaving group. So once again, we have removed a proton in one step, and then we've removed hydroxide here in a second step. So collectively, we've performed this condensation, we've removed water, and our final product here has been explained.